My name is Misha Goffstein. I am a founder and VP of emerging products for a company called AlertLogic. We are a software as a service security provider, so we've been operating with the cloud model for close to 9 years at this point. So we've always been a hosted solution, always have been multi-tenant and single instance solution, and we offer our services through a variety of cloud and hosting providers. So typically if you go to one of the larger hosting providers or cloud providers and look for security services, you'll find AlertLogic under the hood more often than not. The reason I'm here today is I'm presenting for Ed Legzinski of Datapipe, who couldn't be here today. Unfortunately, he had a death in the family and asked me to step in. I worked with him for the last 6 to 9 months, so I was happy to do it, know the subject really well. I'll probably start with an introduction into the moving parts we're going to be discussing. Datapipe is a hosting provider that offers a managed service on top of Amazon. So typically, if you don't want to get hands-on with Amazon, or if you simply want somebody else to manage it for you, Datapipe is a fantastic provider to do that. They'll help you get started. They have a full suite of services built out for that, and those services are in large built around RightScale. So when Datapipe launches Amazon instances for their customers, and they have quite a few customers at Amazon today, RightScale is the tool of choice for them, so they use RightScale extensively for their deployments. Now, for security, AlertLogic is the provider of choice for Datapipe. So that's how things fit together, essentially. Amazon provides the infrastructure capacity. On top of that, there are management tools such as AlertLogic and RightScale, and Datapipe essentially integrates all of them and delivers that to their customers. So as a way of further introduction, Datapipe is really focused on delivering a full suite of security solutions, because one of the hardest problems people face in Amazon deployments is it's easy enough to get started. It's easy enough to spin up AC2 instances, get started with compute and storage. It gets very difficult once you actually have to start deploying security services. So that's one of the things that Datapipe does really well, and their goal is to literally help customers become fully PCI compliant. So if you have to accept credit cards in a cloud environment, that's a very complex thing to do. Datapipe can actually help you get that done. They have a variety of services there. Everything, if you read the PCI standard, there's quite a few things included in that, including two-factor authentication, vulnerability assessment, log management, intrusion detection. That's a full suite of services that Datapipe can help you deploy. So the first question is, why even worry about intrusions, and why worry about them in an Amazon environment? The most obvious answers are really practical. They're really around how are you going to secure your environment, and whether you're going to have adequate controls in place to know when you're being broken into. Have you guys heard of the Sony case with the number of breaches they had over the last year, and number of attacks their network has sustained? In a lot of cases, it's almost certainly a lack of adequate controls. If you were to take a standard PCI test, and PCI gets a bad rap for being a regulation, but it actually specifies quite a few practical steps for security you have to take. And I'm willing to bet that a lot of the Sony network couldn't pass PCI standards as it stood. So the most basic considerations are really practical. First of all, how do you know if your web servers are making connections to botnet command and control servers? If your servers have been broken into, and if they are now being controlled remotely by someone else, chances are they're making connections outbound, they're being controlled by someone else. There's very useful information to know, because it actually hits your bottom line directly, because they will consume computing capacity, your load profile is going to be much higher than you expect, and so on. Obviously, you need to know when somebody's running a vulnerability scan against you, because that's one of the first steps that somebody might take if they were to map you out, figure out where your weaknesses are, and find a path of attack, right? And finally, it's really a practical step for knowing that your development team is taking the right steps. You can't be 100% sure that every one of your partners and the code you deploy from your own developers is 100% free of SQL injection attacks, cross-site scripting attacks, and so on. So knowing when intrusions occur is extremely important, and especially in the last 2 years, we have really switched from the mode of trying to prevent every single attack to being able to respond to intrusions, because one thing we've learned with Anonymous and LulzSec is that they will find a way to break into your environment. If they stay at it long enough, they will find a way. It's simply a practical matter of knowing that you may have a breach, and no matter how much security you deploy, there's no such thing as 100% protection. But being able to be aware of those intrusions early on is extremely important, because then you can actually engage the response process. So the situation that Sony experienced, where they literally couldn't respond to those incidents fast enough, didn't have the processes in place, didn't have enough early warning systems, didn't have the staff to go out there and respond to those things. These are things you should really think about putting in place, and these are exactly the things that are really hard to do in the Amazon environment. And honestly, even if you don't care about these things, if you deploy, if you take credit card transactions online, chances are you have to be PCI compliant, and intrusion detection is one of those core requirements that you have to do. In my experience, and I've spoken to quite a few cloud customers, that's typically not the case. They move forward and they get their deployments done, but intrusion detection is something they leave up to the last minute. That was fine 2 years ago, when most of the people were using cloud computing primarily for development and testing purposes. Now it's becoming production environments, and if you have to be compliant, this is the type of technology you have to be able to deploy. So not surprisingly, when Gartner does their research, one of the first questions they ask is, why haven't you adopted cloud computing, and why have you not been able to convince your organization that you should go out there and start adopting new computing models? The number one and two the answers usually are security. Now, I actually personally believe that more often than not, people actually close their eyes on it and, due to business benefits, actually move forward. But rest assured that once it actually becomes production environment, and once somebody internally, if you work for a large organization, a lot of times it's a department that'll do a deployment, but the security team won't know about it until later. At some point, you're going to have to figure out a way to put controls in place, and the time to figure that out is now, essentially. So one of the most obvious questions is, why is this so much more difficult in public cloud environments than it is in traditional networks? To put it simply, the cloud is just different. It's very much a different computing model. When you think about, has anybody in the room done a network security deployment with an intrusion detection system, an IPS, or anything of the sort? So you know that typically you deploy a network appliance. I would say probably 90% of all security technology today is delivered in some kind of appliance form factor. That appliance form factor is not a good fit for cloud deployments. First of all, you can't put an appliance in Amazon. That's blatantly obvious. But there's a lot of considerations that Amazon users have to think about that appliances typically don't fill. You have to have a service that actually addresses these requirements, and that service has to be built from the ground up. And think about it in terms of being able to accommodate autoscaling, for example, right? Autoscaling is very difficult to do with appliances, because all of those are usually manually configured. So there's really no management APIs available and so on. It's very difficult to deploy security in lockstep with your automation routine. So for example, if you've cracked the code on taking your application, adopting it to a cloud environment, and being able to autoscale it, manage it as a series of roles, for example, chances are you won't be able to do the same with your security controls, because security technology, unfortunately, is a couple of steps behind. There's not a whole lot of companies out there that offer solutions that can be deployed in a cloud environment. Not a whole lot of them offer management APIs. They certainly don't scale down to the smallest consumable units found in cloud environments, right? When you buy an appliance like from Tipping Point or from McAfee, for example, that's usually a $100,000 device that can process traffic at up to 10 gigabit rates. What it can't really do is be cost effective enough to secure a single VM, right? That's not something these devices were built for. So they're built with a certain set of assumptions in mind, that you're going to be putting this on a network and you have full control over that network. You're going to have an ability to cover the entire network without having to deal with changes. These things are fairly immovable. They give it a very large net block which to protect, and it's assumed that whatever you throw into that net block is going to be protected. That's just not the way. That's just not the way Amazon environments work. And those of you that use Amazon right now know that all too well. So specifically, what are the AWS challenges when building security services? If you think about a lot of the security technology out there, a lot of it relies on being able to look at network data and be able to inspect it. So network sniffing is very much a fundamental capability for security practitioners. Every security guy you meet will say that's a fundamental function that I need to have in my tool set, because not only a whole bunch of my products use that, but actually I use that myself. Whenever there is a break-in, I want to be able to turn on a traffic dump, be able to capture traffic, be able to record a series of footsteps that the attacker is making. Amazon doesn't make that easy, right? There's to date no network introspection abilities in Amazon. So if you ever use a span port off a Cisco switch or a mirror port off any other switch, for example, that functionality simply isn't there with Amazon. So it gets very difficult to deploy any security appliance out there. When you listen to security vendors, a lot of times they'll say, we have a fully virtualized appliance, for example. Problem is, there's nowhere to put that appliance. There's no facility to actually give it a network feed of data. Every host is essentially its own autonomous unit, and there's really no ability for you to grab a hold of that network. So the networking abilities for Amazon are getting better. They're actually have taken a quantum leap since a couple of years ago. You can now build VPNs. You can now build fairly robust networks. You can finally move traffic around and be able to build kind of a classic DMZ topology. Whether for better or for worse, I actually don't believe that's the right way to do it necessarily, but you can't do these things at Amazon now. What you can do is actually look at network traffic. That's not an option that Amazon provides today. Second characteristic that is very problematic for any security products out there is that IP address in your Amazon is ephemeral, which means that every time you reboot one of your servers, let's say you reboot an Amazon instance, it has a new IP address, right? That applies not just to all of the instances you're trying to protect, it also applies to those virtual appliances. So if you go to a vendor and they say, don't worry about Amazon, we have a virtual appliance for that, their configuration doesn't change as that network changes, right? So the topology is almost like standing in quicksand. It changes every time there is a blip in an Amazon environment. It changes every time you make a change yourself. So every time there's a new IP address, all of a sudden, imagine there's a whole bunch of devices out there. Let's take a use case like log management, right? They're sending logs to an appliance. When that appliance reboots, they no longer know where to send those logs to. So that level of orchestration, be able to tell those devices where to reconnect and where to continue sending their data, so those services don't quite exist today. There are a few for log management actually, but there are none for network security essentially. Third problem is if you use Amazon, chances are autoscaling is pretty high up on your list for things to accomplish. You want to be able to scale your environment dynamically. You want to be able to manage your services as roles as opposed to individual instances. So chances are what you want to do is be able to say, this is a standard image for my web servers. I'm going to manage all web servers the same, and whenever I need new capacity, my application is going to be smart enough to know I'm running out of capacity for web servers. I'm going to deploy more web instances and provision those automatically, right? That's great. You can do that with computing devices. You can't do that with security right now. So if you want to be able to deploy security services, chances are they don't have APIs extended to you, so you can't actually orchestrate this and bootstrap all the way through to enabling security services as well. So when we took a look at this a couple of years ago, one conclusion we made was this environment's fundamentally different. We can certainly release a virtual appliance, but that's hardly going to solve anybody's problem. In reality, what you really have to do is erase all your assumptions, look at cloud environments and say, here are the operating characteristics of cloud environments. We're going to have to build a service that actually scales with cloud environments and does it intelligently. So it actually adopts to the network as the network grows. It doesn't manage itself based on IP addresses as identifiers, for example. It needs to be purpose built, and it needs to be built from scratch. And that's exactly what we've been working on for the last year or so. Before I go any further, any questions up to this point? About 7 years ago, we asked one of our security guys to design a network for us, right? He came up with 17 DMZs he wanted to deploy, right? Because he actually had that many levels of trust he wanted to be able to implement. In his mind, he didn't want web servers talking to database servers directly. That just didn't make any sense. But that's actually exactly what happens with the DMZ model. It's impractical to have 17 segments, all with different tiered policies. In a Cisco world, for example, they actually inherit they're actually tiered down, right? So they actually inherit some of the controls from tiers above them. So it's a very difficult environment to manage unless you flatten it, unless you have maybe 3 to 4 segments max. And even then, firewall administration gets fairly difficult. I think Amazon Security Groups is actually a much more practical way of managing controls for a flat network like a cloud environment. So I'm personally not a huge fan of DMZ models. But I think they're going to be around as long as we have traditional applications. But I think when you see that tipping point where applications are going to be written specifically for cloud environments, I think you're going to see security guys actually go out there and say, I don't need a DMZ anymore. What I need is a really intelligent implementation of my security groups that can actually be tailored specifically to each role, and that role is going to be applied to every instance that gets booted up for that role, right? So I think long term the DMZ model is probably going away. As the firewalls get absorbed into the software fabric, I think it's inevitable. Firewalls, I mean, the firewall interfaces is really an artifact of traditional firewalls, right? You have X number of NICs on a server or on a firewall. That is what decides how many segments you need. But in reality, you may need many more segments than that. You may have 25 roles that you want to protect, and all of those require different rules, right? There's no sense in putting those into a DMZ, which has the same broadcast domain and so on, right? So we've come up with a unique approach to network security monitoring in AWS environments. This approach doesn't require you to force traffic through a choke point. It doesn't require you to have network access to the Amazon network. So you never have to call Amazon and say, can I get a span port on your switches? The answer is going to be no. They're going to tell you you can't do that. What we do instead, though, is for every cloud instance that you bring up, you install a small agent. That small agent is essentially a soft tap, right? So has anybody in the room ever used physical taps on networks? It's a very simple device. It goes in a network. It essentially copies all the traffic to a monitoring port, right? The soft tap does exactly the same thing, but for each individual instance. So each instance you install, there's a small agent running on it, and that agent is essentially responsible for copying that traffic. That traffic is transported to a virtual appliance that's essentially an alert logic AMI that you spin up. It becomes your monitoring appliance. And the traffic from your instances that you're trying to protect is transported to that appliance over a VPN. So all the traffic is encrypted. The downside of that obviously is there's a small footprint for on each node you're deploying this on. Something less than 5% in most cases, unless you're pushing a lot of traffic, and you're doubling your traffic. So you do have to be conscious of where you do this. And a solution for that usually is deploying your monitoring appliances, your virtual appliance that you get from Alert Logic, in the same availability zone as the devices you're trying to actually protect, right? So the soft taps essentially allow us to have a monitoring the set of eyes on every single instance you deploy. If you automate your deployments, you can actually bundle this package of software with those images and be able to bring them up and provision them essentially instantly, right? So I'll show you what the rest of this looks like, but at the core, that's essentially how we get our hands on the network traffic, right? So you're a host-based idea. It's not a host-based idea solution. There's a reason that we went that route. What's the difference? Yeah, so let me explain. So there are two flavors of intrusion detection solutions. There's network intrusion detection, where you look at network traffic and make decisions based on network flows that you're seeing. What you'll be able to see from that vantage point are network attacks and so on. Essentially, anything that goes over the wire is visible through a network intrusion detection solution. Host intrusion detection solutions are very different, actually, and they look primarily at local memory. They look at syslog output. They look at Windows log and so on. So they actually have a very much a local machine point of view. What they typically won't see are network attacks and so on. But the key reason why we actually considered going the host IPS route, the reason we didn't go that way is because if you read the PCI standard closely enough, they actually don't say that host IDS is acceptable for their requirements. So you actually have to have network monitoring for PCI deployments. Some QSAs may give you a pass on that, but if you read the specific language in the PCI standard, it actually stipulates network IDS. So that's one part of the solution that we built. We actually had to go quite a bit further because obviously just being able to capture traffic isn't enough. If all of your VMs reboot, obviously now they're playing musical chairs and you can't tell what IP addresses they're on. So we actually built a series of services to orchestrate these deployments, made them completely automatically provisionable. So in addition to soft apps, we also built monitoring agents. These agents essentially sit on those devices and report back to our API their location. So if a host changes its IP address, we don't identify it by the IP address, we identify by a certificate that it gets, and we know what it's directed to. So for example, let's imagine a VM reboots, it comes up again, checks into our API, we tell that host, go talk to this, to this appliance. So it'll know exactly which monitoring appliance it needs to send traffic to. So in addition to those agents that check in with us and give us information about health and get directions about where to direct that information, we also have deployed a series of APIs. Those APIs allow you to orchestrate deployments. So if you want to be able to autoscale, for example, you can easily provision a series of appliances and a series of protected hosts, and be able to do that for autoscale situations. I think most importantly, we deployed certificates to each one of these endpoints. That means that the agents that sit on your images and the virtual appliances each have a certificate. That means that only those agents with certificates authorized for that appliance can actually send data to it. And that means that no other Amazon customer is going to be able to send you traffic, and we make sure to authorize them as they come up. So they're authorized essentially on connect time. Even if they reboot, they come back to us and have to reauthorize again. So the problems this solves, obviously, is autoscaling gets much easier. We actually are, so autoscaling we can accomplish now, but we're actually working on a way to do role-based management as well. Right now, we kind of give a certificate to each host, but we don't have a global certificate role for a role yet, and that's coming later on. It enables load balancing and failover, so you can actually say, this appliance is running hot, let's transition X number of these machines to a different appliance, be able to fail them over between availability zones and regions. That's easy to do as well. It offers transport level encryption, so you don't have to worry about somebody being able to pick up the traffic off the, I mean, it shouldn't be possible at Amazon anyway, but it's still not a good reason not to encrypt traffic anyway. And obviously, all of the configurations are pushed automatically. So when a new image comes up and it checks in with us and says, I have a certificate, who should I go talk to? It actually inherits that configuration from the API. So it's never fixed. You never have to worry about having to go in and change configuration files locally. It will essentially learn its configuration information on connect time. So we're going to drill deeper into how the service works. Some of the components we're going to talk about, because what this really is about is a story of how we built this service with Datapipe. So the components we're going to be talking about is there's a customer EC2 environment that could be one of your environments that is being managed by Datapipe. There is the cloud management system, which is technology built by Datapipe that essentially orchestrates all of their Amazon deployments. RightScale plays a big part in that stack. When you become a Datapipe customer, you actually don't have to worry about certificate management and so on. They'll actually do that from their cloud management system, and that's going to be done in the background. So even though those functions are available to you, if you want to automate your deployments, chances are, for most simple installations, Datapipe should be able to handle that without a problem. You'll get a full access to a security portal that essentially will give you all of your security information in a single pane of glass. So no matter how many environments you have, even if you have an environment in EC2 and you want to have it in an environment protected by Alert Logic on-premise, you can actually have it in a single portal and have a single place where you can go in, drill into intrusion detection events. You can have access to log management information, because that's another service that we offer. You can run vulnerability scans, you can run PCI scans, and so on. Incident information is in there as well. And finally, there is the most important part of the solution from a user perspective is really the incident management system. We have a security operations center that runs 24/7. So when incidents are generated, we actually respond to them. We get Datapipe involved. Datapipe helps us investigate those and remedy those for customers. But the incidents you actually have access to as a customer. So you can log into them and drill as deep as you want into them, including packet level details. So it's a full-blown IDS solution you can use, but is also managed for you if you don't want to get hands-on. So this is what the setup process looks like. Datapipe essentially orchestrates the configuration using the alert logic services, and we have a series of APIs exposed to them to do so. It's a fairly simple process. Again, RightScale server templates are involved every step of the way. So essentially what happens is when you deploy your AC2 instances, the only thing you have to do is deploy a small package of agents. It's usually a couple of megabytes in size. They're fairly trivial to deploy and install. And you install certificates that are granted by Alert Logic to identify those hosts to us. Do the same for appliances. So you install X number of appliances. They actually run as Amazon images. So you'll boot them up. It's an Alert Logic built AMI. So the typical best practice is you want to have as many of those as you have availability zones. It'll save you money on traffic because obviously we're sending traffic between availability zones if you only have one appliance. So the more appliances you have, the cheaper your bandwidth costs are going to be. And once you have these packages installed, you're up and running. And essentially, the installation process is extremely simple, especially when Datapipe is involved. They make it very simple for you to do so. So as a managed service, this is really hands-free. You don't have to worry about deploying this stuff on your own instances. Any questions here? So we're going to do an attack scenario. Let's imagine that there's an attacker out there. There'll be me in this case. Datapipe actually has a Drupal service set up in their EC2 environment. It's actually not vulnerable to anything, unfortunately, but we can still attack it with a SQL injection attack. Hopefully, I still have my internet link here, so it'll work. So we're going to do two things. We're going to, first of all, try to enumerate columns in a SQL server through the Drupal application, but also, just because we have time, we might as well also look for admin accounts on that SQL server as well. This will probably won't find anything, but it will actually fire up your security portal with a whole bunch of alerts, because when you're doing security monitoring, it's really not the evidence of successful attack, even though it's useful to know when it has been successful. It's the intent you're looking for, right? When somebody starts to break, what you don't want to know is when you've been broken into. What you do want to know is when somebody's starting to pay attention to you and starting to actually map your network and figure things out. The way it works behind the scenes at Alert Logic is we actually have a fairly intelligent correlation engine that allows us to put together a whole bunch of security events, and it could be thousands of them, into scenarios. And based on what we know about your network and based on what we know about the environment and the attackers, right, because we have a lot of global history for who's attacking you and specific attacks that are launched against your network, it will essentially open an incident and say, it looks like an attack, hasn't been successful yet, but we're going to start incrementing the threat score, because at some point they may actually get to their objective. And depending on what we know about the environment, that could be higher or lower. So for example, if we know that you have a Drupal installation and somebody's launching specific Drupal attacks against the Drupal framework, for example, we'll actually give that a higher threat score, right? If we know that your servers are vulnerable, that will get a higher threat score. So in this case, this will actually generate a threat score of about 60. 60 is a fairly high threat score. That means that this is not an automated attack. This is typically somebody attacking you by hand. Typically means that the target is actually available, and there is a possibility that at least the version matches. We may know that this attack has happened before, because we've actually been running this over and over again. So the attack scale that we use is from 0 to 100. So anything that gets over 50 is a pretty good indication that somebody's coming after you. And we will continue to attach those events to that incident as time goes on, right? So let me show you what that looks like. Do you have a question? Yeah. Okay. So, so the first thing that's going to happen is the incident is going to be identified by our correlation engine. We're going to give that threat score. We're going to give that incident a threat score of 60. Subsequent attacks that happen in the future, will actually continue to be attached to that incident. So that attacker has now been flagged by us, and the future attacks that they launch will essentially be attached to that incident. So you don't have to go in and look at 20,000 different events. You're looking at a single incident. And that incident is actually investigated by both Alert Logic, because we have a 24/7 SOC, and Datapipe security team, because we escalate these incidents to them, and they actually engage with us as soon as we detect something. So as a result of that, you can actually have a hands-free process for incident response. So now you've actually solved the problem of monitoring your EC2 environment for intrusions. You solve the problem of being able to have 24/7 monitoring that's backed by people, and you have somebody to remediate that problem. That's the last mile of what that Datapipe performs. So typically you'll get an email from either us or from Datapipe, depending on what kind of customer you are, and you'll have access to an incident. You can actually go in there, start doing your own investigation, and so on. So in most cases, and we found this time and time again, the most useful detects that we find are not those where somebody's actually been broken into. It's the ones where they're about to get broken into. We can actually do something to stop it. Because attacks take time to launch. It's not always like it is in movies where somebody launches an attack and 3 seconds later the whole internet is compromised, right? That's not the way it works. It takes real effort. It takes real time. Building that scenario over time as the attacks keep coming in and be able to put it all in context is really useful, and that's something that the service will let you do. So the service is available today. It's in beta with the select customers. If you guys are interested in helping us test drive it, we'd love some feedback. We are already extending it to support VPC environments, for example. So that's something we did a couple of weeks ago. So every time we meet a new customer and they have their own requirements, we learn something new. So if you want to jump in and play with it, stop by later on. I'd love to get you into the beta program and show you what it looks like. It's available as a managed service for Amazon exclusively through Datapipe. Starting in early 2012. It's RightScale enabled, so these images and these agents are actually bundled into server templates, so it's easy to deploy them. Again, Datapipe takes care of that, but if you actually automate your deployments and want to have those programmatically driven, they'll give you access to the RightScale environment if you want. Autoscaling support's coming soon. For us, that means role-based management, so that's coming early next year. And sometime next year, we'll actually be making this available as a self-service solution for Amazon and other cloud providers. So if you aren't interested in a managed service of the sort that Datapipe performs, you should be able to buy this as a direct customer and essentially get hands-on with the APIs and provisioning system. So, any questions?